Hello everybody, welcome into another lesson. So today we are going to talk about arcs and central angles of circles. So here we have a circle with the center O, and in that circle we have an inscribed angle at points X and Y. Of course, this is angle XOY. In order for an angle of a circle to be classified as a central angle, the vertex of the angle has to be at the center of the circle. Thus, that kind of gives it away, central angle. The vertex has to be at the center of the circle. So we see here the measure of angle XOY is at 70 degrees. Whenever you have a central angle, you have here, if you see X and Y, that curved part that connect X and Y inside of the angle, that is called the minor arc. The minor arc is inside of the angle. It's the two endpoints of the angle here, X and Y. And the measure of the minor arc, abbreviated with MXY with a curved line above XY, is also equal to 70 degrees. So whatever the measure of your central angle is, that's what the measure of your minor arc will also be. And we denote a minor arc by two letters with a curve above it. Then there's something called the major arc. The major arc is the portion outside of the angle. It's everything that's left of the circle but the angle. So we exclude the angle itself, and we would denote that by the measure of XWY. You always want to have some other point on the circle that's not part of the angle. You denote a major arc with a curved line, of course, above three letters. So if you see two letters with a curve, that's denoting a minor arc. If you see three letters with a curve above it, that's denoting a major arc. To find the measure of the major arc, you're going to use the fact that a circle has 360 degrees. You're going to subtract the measure of the minor arc from that. So in this case, 360 minus 70 degrees. So the measure of major arc XWY equals 290 degrees. So that's really quite simple, honestly. The major and minor arc concepts, that's really not that bad. Okay, now let's do this. We are going to talk about what's called the Arc Addition Postulate. It's very similar to the Angle Addition Postulate, but in this case, this is the Arc Addition Postulate, which is very useful to know. It's going to come in handy here for some exercises, the Arc Addition Postulate. So this postulate states that the sum, not the sum, well, the sum will be in there, but the measure of an arc formed by two adjacent arcs is equal to the sum of the measure of the two arcs. Of course, let me draw a circle here to illustrate. Let's see here. We have here, of course, point O for your center, your origin. And then, let's see, let's draw to here. This will be point A. This will be point B. And I think for that segment, I'm going to choose a different color. For that arc, I'm going to choose a different color for this to denote what we're talking about. So I'll make this purple so I can really illustrate this postulate. And then for good measure, let's draw another one to a point C. Let's draw another radius to a point C. I think this time from B to C, I'll make that red. So we can really appreciate what we're talking about here with this postulate. Okay. And then I have, let's see, AB is going to be, oh, we'll call that 75 degrees. We'll call BC, we'll call that, we'll say that's 70 degrees. Okay, so first let me read the arc addition postulate. The arc addition postulate states that the measure of an arc formed by two adjacent arcs is equal to the sum of the measure of the two arcs. So remember we had the angle addition postulate where if you have an angle that's split into two or more angles, it's just the sum of the measure of the smaller angles inside of that angle, and then you got your whole angle. Well, this is kind of saying the same thing, only with arcs. So, really we want to find the measure of arc AC, right? We want to find the measure of arc AC, which is, minor arc AC. We can do that just like the angle addition postulate. That's going to be equal to the sum of the measure of arc AB plus the measure of arc BC. Really, you can almost think of this like the segment addition postulate also. It's kind of like the angle addition postulate and the segment addition postulate came together. You can almost think of it that way, only you're dealing with angle measures. So we have here, then the measure of arc AC would be equal to the measure of arc AB plus the measure of arc BC. Well, that's going to be equal to, of course, measure of arc AB is 75 degrees. Plus the measure of arc BC, which is 70 degrees, which then means that the measure of arc AC would be equal to 145 degrees. So that's all this postulate is saying, that the measure of arc AC then would be equal to 145 degrees. So that's really a pretty simple postulate to understand, if we're being honest. Alright, so that is that postulate. And then we can talk about congruent arcs also. Just like you have congruent angles in different shapes or even in the same shape, you can have congruent arcs in different circles or in the same circle. And here's a theorem that goes with that. So here's a brand new theorem. This theorem states that in the same circle, I'm just going to abbreviate circle like that. In the same circle or in congruent circles, two minor arcs are congruent if and only if, which if and only if can be abbreviated IFF. If and only if their central angles are congruent. So let's see here. Let's illustrate each case. Let's start with the same circle. Let's start with the same circle here. Alright, so we have here that this theorem states that in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So here we have the measure of central angle AOB is equal to 90, denoted by the perpendicular marker. So we have the measure of angle AOB being a central angle of the circle is equal to 90 degrees. We also have the fact that then you have the measure of angle COB, which is another central angle, is also equal to 90 degrees. Therefore, we can say that minor arc AB is congruent to minor arc BC. We can totally say that. Because remember, the measure of your arc is also the measure of your minor arc is also the measure of your central angle. So since you have two congruent angles here, central angles, they're both 90 degrees, that means arc AB is congruent to arc BC. Now let's illustrate this with two different circles. Alright, I made it easy. Both of these circles have two 90-degree central angles, right? Okay, so the theorem, I'm going to read it again. In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Well, we can go ahead and give you the information that circle O is congruent to circle P. Circle O is congruent to circle P. You call a circle, how you name a circle is by its center, if that makes sense. So we have that circle O is congruent to circle P. We even have their central angles congruent. If you have AOB, the measure of angle AOB, the central angle of circle O, is equal to 90 degrees. What else? And then in circle P, you have the measure of angle CPD. The central angle there is also 90 degrees. So since we have two congruent circles here with two congruent central angles, that means the minor arcs AB and CD are congruent. So therefore, the measure of minor arc AB is equal to the measure of minor arc CD. Or you could just simply say arc AB is congruent to CD. Again, we know that congruent and equal really mean the same thing. It's just a different way of writing it. So that's how that theorem works. Now we're going to go on to some exercises. I think we'll do some exercises here about these. Alright, so let's draw a circle. Alright, so for the next few exercises, our goal is to find the measure of angle 1. We're going to find the measure of angle 1. This one's fairly easy. You definitely have a central angle of angle 1. The minor arc is 85 degrees. Well, what do we know about minor arcs and central angles? They're congruent. So therefore, the measure of angle 1 would also equal 85 degrees in this case. Pretty straightforward since the minor arc and central angle are always congruent. How about the next one? Here's angle 1. This one is a little different. So we would need to, first we have central angle 1. We will ultimately want to find that. In this circle we have the measure of the major arc, which is 280 degrees. Well, in order to find the measure of the minor arc, that's just going to be 360 minus the major arc, right? So you'll take 360 degrees minus the 280 degrees, which of course is going to equal what? 80 degrees. So the measure of the minor arc is now 80 degrees. So since we've obtained the measure of the minor arc, we know that the central angle and the minor arc are the exact same. They're both congruent. So the measure of angle 1 would also be 80 degrees. Alright, that one still wasn't terrible. What will be next? Oh, this is a real good one. All right, so something very interesting here. We have central angle 1, then we also have another central angle that it touches. They give you the measure of the minor arc of this central angle is 150. Well, we still want to find the measure of angle 1, but here's the thing. There's a shortcut. Instead of subtracting all this from 360 and trying to figure out these two angles, what do we notice here? We have two intersecting lines, right? What is true of angles and intersecting lines? That vertical angles are congruent. Vertical angles are definitely congruent, right? Well, this central angle, of course, is equal to the measure of the minor arc, which would give this central angle to be 150. That means since vertical angles are congruent, that means the measure of angle 1 would have to equal 150 degrees. So that was a nice shortcut you can use, the fact that vertical angles are congruent. So instead of sitting there and doing a bunch of 360 minus 150 and then another 30 math, I mean, you can do it that way, but why torture yourself? Okay. See what we got now. Here's angle 1. So we have a semicircle here, right? We got a semicircle, which a semicircle is half a circle. Now, the degrees of a semicircle then would be half of 360, which would be 180. Well, we see this arc here from this central angle is 130, so the rest of the distance to be 180 would be 50, right? That means this minor arc here would have to be 50, which would then make the measure of angle 1 equal to 50 degrees. So that one also wasn't too bad. You're just working with a semicircle. See, here's angle 1. This is 68 degrees in here for a central angle. This is 240 degrees for the major arc. We still, of course, want to find the measure of angle 1 ultimately, but we have the measure of the major arc being 240, right? We have the measure of the central angle here next to angle 1 being 68, which means the minor arc from that 68 degree angle is also going to be 68 degrees. So all we need to do now is solve for the minor arc for central angle 1, and then we'll have the measure of central angle 1. So in order to do that, we're going to take, let's see, we'll take 360 degrees. Well, here, let's see. So we'll say minor arc 1. I'll call this minor arc 1. Minor arc 1 equals 360 degrees minus 240 degrees minus 68 degrees. So basically, you're going to take the sum of these two away from 360. Which 360 minus 240 is what? That's 120 degrees minus 68, which should give you what? 52. So the measure of this minor arc is going to be 52 degrees, which would have to mean then that the measure of angle 1 is also 52 degrees. Since the minor arc it's attached to is also 52 degrees. So the measure of angle 1 would in fact be 52 degrees in this case. All right, what's next? Another good one. Go straight up, straight down, straight to the right. Yes, then we go straight to the left with the red. Alright, this is a 90-degree angle. Here's central angle 1. This arc here is 35 degrees, right? Okay. So we want to, again, find central angle 1. This is actually not as bad as it looks. If you have a central angle here of 90 degrees, that means this minor arc here is also 90 degrees. And then we see that angle 1 is very clearly inside of a semicircle, right? Which means all you can get up to is 180 degrees. So we need to start by finding minor arc 1. So minor arc 1 is going to be equal to, this time, 180 degrees, because it's inside of a semicircle. You can only reach 180 degrees in a semicircle. That'll be minus 35 degrees minus 90 degrees, which would then give you, let's see, what's 180 minus 35? That'd be 145 minus 90 degrees, which would then simply give you 55 degrees. So the minor arc attached to angle 1 is going to be 55 degrees, which, and then since angle 1's a central angle, that means that the measure of angle 1 would also be 55 degrees. So that wasn't too terrible. All right. Let's see here. I got a few more exercises. Let's draw the circle for the next several exercises. Then we have, let's see, central angle 1 and central angle 2. So let's see what they give us. They give us that the measure of minor arc CB is equal to 60 degrees in this case. Find the measure of angle 1 and the measure of angle 2. So we need to find both of those measures. So let's start then. Since we were given minor arc CB, it's clear that the central angle 1 is definitely attached to it, right? So that would have to mean that the measure of angle 1 would also be 60 degrees. That was an easy one. Now what's not as easy is finding the measure of angle 2. But it's really not that hard, because you have yet another semicircle you're working with. If CB has an arc length of, it has an arc measurement of 60 degrees, and this is inside of a semicircle, you can find minor arc CA by taking 180 minus 60, that would give you 120. Which would then have to mean then that the measure of angle 2 would have to equal 120, since it's the central angle corresponding to that. So the measure of angle 1 is going to equal 60. The measure of angle 2 would be equal to 120. All right, let's see what they give us now. They give us for the next exercise that the measure of arc CB equals 70 degrees. We still want to find the measures of angle 1 and angle 2. Well, CB is the minor arc that's attached to central angle 1. So that means the measure of central angle 1 is going to be congruent to the measure of arc CB. So the measure of angle 1 would have to also be equal to 70 degrees. And let me write that this arc is 70 degrees because this is also inside of a semicircle, which means that the remaining arc AC or CA, however you want to call it, would just be 180 minus 70. That arc would end up being 110 degrees. Which would mean that central angle 2 would have to also be 110 degrees. So what you should get here for this one is that the measure of angle 1 is equal to 70 degrees. The measure of angle 2 is equal to 110 degrees. Let's see what they give us now. What do they give us this time? They give us that the measure of angle 1 equals 56 degrees. Find the measure of minor arc CB and the measure of angle 2. I think we'll actually start with the measure of angle 2 this time. If you can clearly look at this, you see that together angles 1 and 2 form a straight line. They form a 180 degree angle, right? So that means the measure of angle 2 is simply going to be equal to 180 degrees minus the measure of angle 1, which was 56. Well, what's 180 minus 56? So that'd be 124. So the measure of angle 2 would have to equal 124 degrees. Easy enough. And then actually the measure of arc CB is also easy because it's the central angle it's attached to, angle 1 is going to be congruent to that arc. So that means the measure of minor arc CB would have to be 56 degrees since it's attached to central angle 1. So that wasn't too terrible. All right, what do we got next here? We got that the measure of angle 2 is equal to 25 degrees, which if you look at it, it's very clearly not, but that's just what they're giving us here. We need to find the measure of angle 1 and the measure of minor arc CB. So we have here first that the measure of angle 2 equals 25 degrees. Again, looking at this, angles 1 and 2 form a 180 degree angle. So to find the measure of angle 1, you're simply going to take 180 degrees minus the measure of angle 2, which is 25. Which would have to mean then that the measure of angle 1 would end up having to be 155 degrees. So the measure of angle 1 is 155 degrees then. And then all we have to do now to find the measure of minor arc CB, since we know that the measure of central angle 1 is 155 degrees, that means the minor arc that touches it is going to be congruent to it. So the measure of minor arc CB would also equal 155 degrees. And then I got one more for this circle, and then we got a few more with another circle. This one's got a twist on it. This one's going to have a twist on it. So now this is where it gets interesting. The measure of angle 2 equals x. Find the measure of angle 1 and the measure of minor arc CB. Okay, so we have the measure of angle 2, a central angle is x. Well, again, looking at this, 1 and 2 together form a 180 degree angle, right? So to find the measure of angle 1, you're just going to take 180 degrees minus the measure of angle 2, which would just be x. And in fact, that's as far as we can go, is the fact that the measure of angle 1 is equal to 180 degrees minus x. Which, since your central angle has a measure of 180 minus x, that means the measure of the minor arc it touches also has that measure. So the measure of minor arc CB would also have a measure of 180 degrees minus x. So this exercise was to get you to also start thinking algebraically at the same time while thinking geometrically. Alright, should be 5 more exercises here. Nope, that isn't what I wanted to do. I did not want to connect those. I wanted to connect A to D, I'm pretty sure. Yes. Okay, here we go. So we got a really fun circle. You have a circle with a couple of triangles split up here in each half of the circle. Very interesting. They give you at this time that the measure of minor arc CB is equal to 70 degrees. You're also given that the measure of minor arc BD equals 30 degrees. Find the measure of angle COD and the measure of angle CAD. So we are given two arc values. We need to find the measures of angle COD and the measure of angle CAD. Well, let's start here. CB has a measure of 70 degrees, right? And then BD has a measure of 30 degrees. Okay? So if we're going to consider now the whole angle COD, what is that going to be for us? It's going to simply be both of these arcs put together, which would be 70 plus 30. That means that the measure of angle COD, because if you look at this here, right, COB, angle COB is your central angle, which would be 70 for this arc, and then BOD is the central angle for this arc being 30. So now if you want to get the measure of angle COD, you're simply going to do what? Add the 70 and 30, that would give you 100. So the measure of angle COD would be 100 degrees. Now all that's left to do is find the measure of angle CAD. Well, how on God's green earth are we going to do that? It's not as bad as you think. Let me explain. So here in this top half of the semicircle, to find angle COA, we just need to subtract 70 from 180, which is going to give us what? 110. This gives us 110 for angle COA, right? Okay, so now we know that OC and OA are going to be congruent. Why? Because they're both radii of the circle. So that's going to help you out. You can now apply the isosceles triangle theorem to figure out these missing angles here. So let's go into that. So let's call these missing angles X, because they're going to be congruent, right? Think about it. You have two congruent sides. The angles opposite those sides are also congruent. So in order to find the missing angles here, we're just going to add all these up to 180. So you would take X plus 110. You'll set all that equal to 180 degrees, which would then of course give you 2x equals 70 degrees if we're simplifying this, which means x is equal to 35 degrees. So therefore your missing angles of this triangle would end up being 35 degrees. Great, so now we have solved for some missing angles of this triangle, but what about this triangle? Well, again, let's try to find angle AOD. It's clear that angle AOD and then this angle here form 180 degree angles, which means what? Maybe I'll make the O a little bit smaller so I can write, eh? We'll call this point O here. That's point O, okay? Let's raise that up actually. That's point O. Well, 30, so if you take 180 minus 30, what are you going to get? This angle here would have to be 150 degrees. But since OA and OD are radii of the circle, they're going to be congruent. So now, all we have to do is try to figure out the two missing angles for this triangle. We'll call those Y, because why not? So then you'll take Y plus 150 degrees, set that equal to 180 degrees. Well, that's going to be 2y is equal to 30 degrees, which would then have to mean that y equals 15 degrees. So your missing angle measures are going to be 15 degrees. Now that we've solved for these missing angle measures, we can go ahead and find the whole sum of angles CAD. Just use your angle addition postulate. The measure of angle CAD is equal to what? The measure of angle CAO. The measure of angle CAO plus the measure of angle OAD. Which would be what? Measure of angle CAO is 35, plus then the measure of angle OAD is what? 15. So then you should get that the measure of angle CAD is going to be equal to 50 degrees. So the measure of angle CAD would actually be equal to 50 degrees. Now, in a couple of lessons, there is something about inscribed angles that are not central angles. There will be a theorem that states that the measure of an inscribed angle is equal to half the arc that it intercepts, but we're not there yet. But the values you were looking for were the measure of angle COD, which is just the measure of these two minor arcs put together. And then after figuring out missing angles, you come up with the measure of angle CAD being 50. Got a few more exercises with this one. I feel this is a very important one to do here. Why don't I actually put point O right here instead, in the bigger triangle up north? There we go. Okay. This time we are given that the measure of minor arc CB is going to be equal to 68 degrees. We are also given that the measure of minor arc BD is going to be equal to, well, actually it's 60 and 28, I believe. I had that one wrong. This is 60 and 28. My bad. I don't want to start out wrong here. So the measure of minor arc CB is equal to 60 degrees. The measure of minor arc BD is equal to 28 degrees. We're still tasked with finding the measure of angle COD and the measure of angle CAD. let me just refine these lines a little bit here since I butchered them a little bit. Alright, that should be good. So, let's start with what we know before we try to find anything. We have here the measure of arc CB is 60 degrees. Wouldn't that have to mean then that the measure of angle COB being the central angle to that would also have to be 60 degrees? Alright. Actually, I want to keep that one on there for a reason, but okay. And then we know that the minor arc BD has a measure of 28 degrees. Which means that the measure of angle BOD being the central angle would also have to be what? 28 degrees. So now, isn't it true that the whole measure of angle COD is going to be equal to the measure of angle COB plus the measure of angle BOD? Which would have to mean it equals 60 plus 28. Which means that the measure of angle COD would simply equal 88 degrees. Alright, so that wasn't too terrible. Now we need to find the measure of angle CAD. Well, if you look at, let's look at this triangle here up top. If you have a semicircle here, that means angles COA and COB are supplementary, meaning they add up to 180. So, if you take 180 minus 60, what are you going to get? 120. So the measure of angle COA is 120. Now we need to solve for some missing angles again here, because ultimately we want to find what? CAD. So let's call these missing values here X. So let's see, we'll take X plus 120 degrees, set those equal to 180 degrees, which would have to mean that 2x equals 60 degrees. So therefore X would be equal to 30 degrees. So your missing angles here would have to be 30. I'm not even worried about this angle, but this angle here, angle CAO, is 30 degrees. Now, let's try to go for angle OAD. But first, we know that if we look at this, angle AOD and angle BOD are supplementary angles in this half of the circle, right? For this semicircle. If you take 180 minus 28, you should get 152. So this angle here is 152. Let's call these Z for the missing angles. So now all you have to do to find the missing angle here is you'll take, let's see, let's write in a different color for that one. Let's take Z plus 152, set that equal to 180 degrees. And by the way, we're getting that these angle measures are the same because radii of circles of the same circle are always congruent, therefore giving you isosceles triangles. So we're using the isosceles triangle theorem to figure out those angles. But if we simplify the Z plus 152 equal to 180, you end up getting that 2Z is equal to 28 degrees, which would have to mean the missing angle is equal to 14 degrees. So this missing angle here is going to have a measure of 14 degrees. Now for the final part, we're just simply going to figure out the measure of angle CAD. which of course is equal to the measure of angle CAO plus the measure of angle OAD, which is going to be equal, CAO has a measure of 30 degrees, and then the measure of angle OAD is 14 degrees. So that means that the measure of angle CAD, is 30 plus 14, which is 44 degrees. So we get that the measure of angle COD is 88 degrees, the measure of angle CAD is 44 degrees. Should be just 3 more exercises with this, but we're going to change it up a little bit. We're going to figure out some other things. All right, let's see what we're given this time. I might actually just do 2 more instead of 3, but let's change it a bit here. Why don't we do this one? The measure of arc CB is equal to 66 degrees. What else do they give us? That the measure of angle COD, the whole angle, is going to be equal to 100 degrees. So what are we to find? We're to find the measure of arc BD and the measure of arc, and find rather the measure of angle CAD. So we have a little bit different information this time. Let's start with what we know, that CB is what? 66 degrees. We know that the whole measure of angle COD is 100 degrees. Well, angle COB is the central angle to the 66 degree arc, right? So that means central angle COB also would have to be 66 degrees. Now, the whole angle COD is what? 100 degrees. We want to ultimately start by finding the measure of angle BOD, since that's a part of angle COD. So the measure of angle BOD would equal the measure of angle COD minus that 66 degrees, which is going to be equal to 100 degrees minus 66 degrees, which means the measure of angle BOD would have to equal 34 degrees. So now we found this angle here to be 34 degrees. Well, if BOD is a central angle to arc BD, that means that arc BD also has to be 34 degrees. So we found the measure of arc BD. That one's 34 degrees. And now we should be back to normal here, being able to find the measure of angle CAD. So the measure, let's see, we know that angle COA and COB are supplementary, right? They form a straight line. So that means you define angle COA, all you're going to do is take 180 minus 66, which would give you 114. So that angle is 114. Let's now find the missing angles. So again, we'll just call these missing angles x. So go ahead, take 100, let's see, we'll take x plus 114 degrees, set that equal to 180 degrees, which would have to mean that 2x equals 66 degrees. So x, the missing angle, is 33 degrees. So we got here the first part of angle CAD ultimately, which is angle CAO. That's a 33 degree angle. Now we need to look at down here to find the second half of angle CAD, which would be angle OAD. Well, again, angles AOD and BOD are also supplementary angles, right? So you're just going to take 180 minus 34, which would give you 146 for that angle. So we'll call these Y, which now we're just going to take Y plus 146, set that equal to 180 degrees, which would have to mean then that 2y equals 34 degrees, which means that the missing angle is 17 degrees. So we only care about the half that's part of angle CAD. So now you have two parts of angle CAD. You have 33 and 17. So the measure of angle CAD is equal to the measure of angle CAO plus the measure of angle OAD, which would have to equal 33 degrees plus 17 degrees, which means the measure of angle CAD would have to equal 50 degrees. So the measure of arc BD is 34. Let's put a box around that for the answer. The measure of angle CAD is 50 degrees. One more exercise, we're done. Now this one's going to be fun. Because what do they give us? They give us the measure of arc CB is equal to P. They give us that the measure of arc BD is equal to Q. So then we got to find the measure of angle COD and the measure of angle CAD. So this is an algebra problem. So the measure of arc CB, start with what we know, is P. The measure of angle BD, or rather arc BD, is Q, which means each central angle, COB, would have to have also a measure of P, and angle BOD, that central angle, would have to have a measure of Q. So the measure of angle COD is equal to the measure of angle COB plus the measure of angle BOD, which means, in other words, the measure of angle COD is simply going to be equal to P plus Q. That's as far as we can go for that. The measure of angle COD is equal to P plus Q. Now we got to find the measure of angle CAD. Well, again, we have supplementary angles here, right? We want to find the measure of angle COA before we go anywhere. To do that, you just take 180 minus P, and that's what you'll get. The measure of angle COA is 180 minus P, which then means you have two congruent angles here. We need to find angle CAD. We'll call these missing angles X again. So what you're going to do is take your X plus 180 minus P. You'll set all that equal to 180, which is ultimately going to give you 2x equals P, which the missing angle would simply be 1/2 of P. So yes, this can turn fun real quick, since we're doing some algebra problems. So this missing angle here is 1/2 of P. Now, if we look at these two angles, angles AOD and BOD, they're supplementary angles. You just take 180 minus Q, you'll get the measure of angle AOD, which would be 180 minus Q, which means you're going to end up in a similar situation here. You'll end up getting 1/2 of Q for the measure of angle OAD. Now, we just go on to find the measure of angle CAD, which is going to be equal to the measure of angle CAO plus the measure of angle OAD, which means the measure of angle CAD is equal to 1/2 of P plus 1/2 of Q. Or you could factor this out and say 1/2 of P plus Q. Those are two ways you can write the answer here. So we got that the measure of angle COD is P plus Q. The measure of angle CAD is 1/2 of P plus Q, or 1/2 of P plus 1/2 of Q, however you prefer to write it. So that's it for this lesson. Next lesson, we're going to talk about arcs and chords. So I hope everyone has a great night. Take care.